Example 2, find the volume of the solid obtained by rotating the region bounded by y equal to x square and y equal to x that lies in the first quadrant, and we want to revolve about the y-axis. Alright, so let me sketch first. Sorry. So we have y equal to x square. So define only in the first quadrant. Actually, the graph is similar with the previous example, example 1. So we have y equal to x square. And then we have y equal to x. So this one is parabola, and then y equal to x is a straight line. So here is our region. This is our region bounded by these two curves from, so we need to calculate this intersect point here. Okay, now we want to revolve about the y-axis. Okay, we want to revolve about the y-axis. So we want to revolve here about the y-axis 360 degree. So if you revolve about the x-axis, then you will have the solid, okay, where you have another region, you move, then you will have also the same region in your left or in the second quadrant here. Okay, so we should have something like this. All right. So it gives you like a solid with the hemisphere. Okay, so from here, again, you must decide which function represent your outer radius and which function represent your inner radius. So if I make a circle, okay, so if I make a circle, so I will have if this is the center, so I will have this my capital R. This is my capital R, where my capital R is the radius that touching your this function. So capital R given by y equal to x square here. Okay, if you can see here, your capital R, your outer radius, touch the outside function here, which given by y equal to x square. Then if I have another circle here, okay, the inner circle here, okay, so now I will have this, okay, never mind, use on this side, okay, so I will have this as my small r. So this should be my inner radius. Okay, this should be my inner radius. So you can see this inner radius touch your inside function. Okay, touch your inside function here, which given by the straight line. So inner radius represented by y equal to x. Okay. Alright, so now let's calculate the volume. So before we calculate the volume, we find the point of intersection first here. Okay, actually point of intersection similar with example 1. So solve these two functions simultaneously, x squared equal to x, which I get x squared minus x equal to 0. Then I can factorize this. So it gives me x equal to 0, x equal to 1. So x equal to 0 here. And then here is x equal to 1. So if x equal to 1, I substitute here into these two functions, I will get also my y here. Y also equal to 1. At this point, y equal to 1. Alright. So second, we decide our outer radius and inner radius. So outer radius is our capital R, okay, given by, okay, remember because we want to rotate about y-axis, so this is your capital R, okay, but we want to rotate about the y-axis, so we must to rewrite this function. So here we will have fy equal to x equal to square root y. Okay, so outer radius are given by fy equal to square root y. And then our inner radius given by small r here. So if we rewrite, we still have gy equal to x equal to y. So inner radius is gy equal to y. Okay, because we want to rotate about the y-axis, then the variable must be in terms of y. Alright, so now we calculate the volume by using this formula. So V equal to, so volume of the solid, okay, for this region bounded by these two curves from 0 to 1 by using Washer method formula. Okay, this is the Washer method formula. Okay, this is Washer method formula. So we will use this formula. So we will integrate from 0 to 1. Okay, C0 D1. And then pi time with, so Fy, your outer radius square. So square root y square. And then minus Gy, your inner radius square. With respect to y. So I bring pi outside, constant, so 0 to 1. So I expand and simplify this. So square root y square, I get y. And then minus y square, with respect to y. So now I continue my evaluation of my integral. So v equal to pi. So integrate this, I get y square over 2 minus y cube over 3 for the limit from 0 to 1. Okay, so pi, substitute 1, I have half minus 1 over 3 and then minus 0. Alright. So if I simplify this, I should get, so 3 minus, so expand here, so pi 3 minus 2 over 6. So therefore I should get 1 over 6 pi unit cube. Okay, so this should be my volume. So this should be my volume. Alright, 1 over 6 pi unit cube. Okay, so if I can show you the maple, it's more clear in terms of sketching. So the same problem, volume, we want to solve by using Washer. For example, 2, y equal to x squared, yx. Resolve about the y-axis. So if I plot these two functions in the same axis as we did before, so we have this curve. So this is our region bounded by these two curves from 0 to 1. Then if we resolve about the y-axis here, okay, so you will have this solid here. Okay, so if you can see here, if you can see this solid, so outside here you have the y equal to x square function here, okay, parabola. And then inside here you can see you have this straight line here. Okay, you have this straight line, the red color here. If you can see, you have the straight line. If I can make this bigger, you can see we have this straight line here. Okay, so remember, we decide the outer radius given by y equal to x square, but we rewrite into square root y, and the inner radius given by the straight line. So same, if you can see here, this is our inner function. Okay, straight line, this is our outer function given by the parabola. Alright. Then if we calculate the volume of revolution as what we did, we get pi over 6. Okay. Example 3. Find the volume of the solid revolution when the region bounded by the curve y square equal to 8x and y equal to x square. And then we want to revolve about the 360 degree about the x-axis. Alright. Okay, so the first one we have y square equal to 8x. Actually, if I rewrite this, I get y equal to square root 8x. And then we have another function y equal to x square. Alright. So let me sketch first. So did not mention about which quadrant. So we sketch first and then we decide. Alright. So y equal to x square. I sketch the parabola first. So y equal to x square. We give you this one. The parabola here. Okay. This is y equal to x square. And then y equal to square root 8x is actually the radical. So the square root only defined at positive area, because if negative, if x negative, you will get. So this function only defined in when x is positive area. X is positive, because if x negative, it will give you imaginary, so we only consider at the real value. So we only interested at this x here, positive x here. So square root 8x, you will have something like this. Okay, so this is for y equal to square root 8x. So this is our region bounded by these two curves. So next we need to calculate this point of intersection here in order to know the limit of integration, or in order to find the interval of your x here. Okay. So now you want to revolve this region, okay, about the x-axis. So we revolve about the x-axis 360 degree. Okay. So this will give you will have a solid. So you will have another region here, okay, when you rotate. So this will give you some kind like this. Sometimes sketching is also very challenging to me. Alright. So we will have this. Okay, so assume this is symmetry, okay. All right. So later we will calculate what is the x here. All right. So now let's check for inner radius and also outer radius. So if I make a circle, okay, let's say this will be your center here. So if I make the bigger circle here, so my bigger r or my outer radius is given by, okay, my outer radius touch the outside function here, which is defined by y equal to 8x here. Okay, so you can see here. So outer radius given by y equal to square root x. Okay. And then if I can have my small circle here. Okay, small circle here. So this will represent my small r or my, okay, this will represent my inner radius. So if you can see here, my inner radius touch this curve, okay, inside curve here. All right. So my inner radius represent by this function. So my inner radius given by y equal to x squared. All right. So now we can calculate the volume. So before we calculate the volume, let's find the point of intersection. So point of intersection, I have y squared equal to 8x and y equal to x squared. So if I substitute y equal to x squared into this y, so I should have x squared equal to 8x, which is x power 4 minus 8x equal to 0. So if I factorize x cubed minus 8 equal to 0, so I will get x equal to 0, x cubed equal to 8, which this I will get x equal to square root 3/8 equal to 2. Then I will have x equal to 0 and x equal to 2. Therefore, here x equal to 0 and then x equal to 2 here. So this is my limit of integration. Okay, lower limit and upper limit. So second, my outer radius. Okay, outer radius given by this function. So outer radius I define as fx equal to square root x, square root 8x. Okay, I missed the x here. And then inner radius I define as gx equal to, so this is my inner radius, x squared. So now I can calculate the volume. So we revolve about the x, so integrate from 0 to 2. Okay, this is your upper limit. Pi fx squared, so you have square root 8x squared minus gx squared with respect to x. So I bring pi outside. So square root x squared, you get 8x minus x power 4 dx. Alright. So continue evaluate this integral. So you will get 8x squared over 2, so 4x squared minus x power 5 over 5 from 0 to 2. Okay, so now I substitute the limit, so pi 4 2 squared minus 2 power 5 over 5 and then minus 0. Okay, minus 0. So if you calculate by using your calculator, you will get your V equal to 48 over 5 pi, because this is volume, so unit cube. So this is our solution. By using washer method, we get this volume for our solid here, 48 over 5 pi unit cube. Okay. So let's look by using Maple. So if I plot these two functions in the same axis, so we will have this. Okay, so this is our region bounded by these two curves. Alright, so from the limit 0 to 2, then we want to rotate or revolve about the x-axis. So let's look what solid we have as what we sketch. So we will have this solid here. Okay, so if I can show you. So the blue color here represent your author function actually. Okay, your author function given by square root x. And then inside here, if you can see, we have the, okay, let me make this bigger. So you can see inside here, you have the parabola here. So the parabola here represent, okay, you can see you have the parabola here. So the parabola here represent your inner function, which is the x square, as what we did before. Okay, inner function given by your x square here. Same, you have the inner function parabola here, x square. Okay, and then the outside here is your square root x, square root 8x. Okay, alright, very nice. So if you calculate the volume of revolution as what we did by using the formula, we get 48 over 5 pi unit cube.